Good morning, everybody. This video is going to be going over the 2.4 exercise that you're doing in class. So hopefully some of you guys have already finished this up, but if you're still working on it, that's okay. I'm going to be walking you through it here on 2.4 video. So exercise 3 tells us, it doesn't want us to actually calculate this out. It just wants it to check your knowledge on whether you understand the positive and negative rules when multiplying anything, either be fractions or integers. And so just as a reminder, if we are multiplying the same sign, that's either a positive with a positive. One moment while I get my Apple Pencil to work. There we go. Either a positive with a positive, so positive multiplied by a positive equals a positive. And then a negative multiplied by a negative equals a positive. So, and then yesterday somebody asked me why it is that a negative times a negative will cancel out and equal a positive, and it's actually a really surprisingly complicated explanation. I'll put the video in one of our Google Classrooms in case you're interested in watching it, but it is just about a 5 to 6 minute explanation. But it is something good, worth knowing. But just know that a negative times a negative is going to equal a positive. And then lastly, a positive times a negative, that's going to equal a negative. Here we go. So just remember that positive times a positive equals a positive, negative times a negative equals a positive still, and then positive times a negative equals a negative. And you're seeing all of the notifications pop up of people making fun of my last name. Okay, so exercise 8 asks us to multiply these two fractions, which I was surprised to see people get a little confused on this one. But let's knock it out. This is -1, and then remember that when there's nothing in between two numbers, just set a parentheses, then that's a multiplication operation. So this is -1 times -3.5. But we know that 1 times any number is going to equal the same number. And then a negative times a negative is going to equal a positive. So I'm going to go ahead and let you figure the rest of that out, but don't overthink it. Okay, exercise 10 is about dividing fractions. Now, we never divide fractions, and let me show you why we never divide fractions. If we were to do -7 over 10 and divide it by 2 over 5, -7 divided by 2 is -3.5 or -3.5, and then 10 divided by 5 is 2, and now we have a fraction and a decimal in the same whole thingamajiggy. So we don't want to have that. We don't want to have a fraction in our decimal because that's kind of weird, because that 3.5 is also could be written as -3 1/2, and we wouldn't want to put that over 2. So the easier way of dividing fractions is by doing the keep change flip. So I'll do an example here. I'll do 6 over 9, -6 over 9 divided by 3 over 5. So if I were going to do this example, which isn't going to give you the answer to these exercise 10, but if I were to do this example, I want to do a keep change flip. And this is going to give me -6 over 9, change the division to a multiplication, and then the 3 over 5 changes to its reciprocal of 5 over 3. Reciprocal. Good vocabulary word to know. And then we're going to need to multiply this out. -6 times 5 is going to give you -30, and then 9 times 3 is 27, which can simplify into -1 and 3 over 27. Whoops, I ran out of space. Which further simplifies to -1 and 1/9. So the only thing when dividing fractions to really know is that you need to do the keep change flip. And the reason we don't divide fractions is because we'll end up with a decimal in our fraction, which is something we don't want. Let's see all the ways that people are making fun of my names real quick. Because Max did not pronounce my name at all this morning, and so I said Mr. Who to all the teachers, and they said Mr. Albino, Mr. Albumin, Mr. Album, Mr. Abacus, Mr. Abacab, Mr. Abracadabra, and that's it. Let's go back to notability. Okay, So exercise 15, question 15 is another dividing fractions problem, and then you're going to do this just the same way you did the other one. The only thing is you're going to turn these into improper fractions first. So you're going to want to turn that negative 10 and 2/7 into its improper form, negative 4 over 11 and 4 over 11 into its improper form, but I want to teach you a really good trick on this one. So I'm going to turn these into their improper fractions, which is going to give me negative 72 over 7 divided by negative 48 over 11, and then I'm going to keep change flipping on this. So negative 72 over 7 times 48 over 11, that's the reciprocal. Whoops, that's not it. Times 11 over negative 48, that's the reciprocal. And then there's a really neat trick with this. Whenever you are multiplying fractions, you can actually take a look at their diagonal numbers, and if the diagonal numbers simplify, then we can simplify the fraction before multiplying them. And we call this the butterfly method. I'm just going to put butterfly effect because it sounds cooler. So we're going to do the butterfly effect here. And what that is that we can take a look at these diagonal numbers and see, does 7 and 11, do 7 and 11 simplify? And if they do, we can simplify them before actually multiplying this out. So 7 and 11 do not simplify, but what about 72 and 48? So 72 and 48 should kind of ring a bell to you because there's 48 hours in 2 days, there's 72 hours in 3 days, there's 24 hours in 1 day. So you can actually simplify 48 and 72 not just by 2, not just by 4, but you can actually simplify it by 24. That would be the greatest common factor that they have. And if we simplify that out, negative 72 divided by 24 is going to give me negative 3 over 7. And then 11 over 48, 48 divided by 24 is going to give me negative 2. So what I just did there is I took the 72 and the 48 and I simplified them down. Now this can be simplified by 2, which would give me 36 and 24, which can be simplified by 2, which would give me 18 and 12, which can still be simplified by 2, which would give me 9 and 6, which can be simplified by 3, which would give me 3 and 2. So instead of doing the 2, 2, 2, 3, I just decided to take all these numbers, realize that they multiply to equal 24, and simplified 72 and 48 by 24 because I recognize that those are the amount of hours that are in 2 and 3 days. And then now that I've simplified that down, it makes my actual problem way easier because I'm not multiplying 72 times 11 anymore. That would have taken a while. And 48 times 7 would have given me huge numbers both on the top and the bottom to simplify. Now I just have to do negative 3 times 11, which is negative 33, over 7 times negative 2, which is negative 14. The negatives will cancel each other out. And then 33 over 14 will simplify into a smaller number. So hopefully that helps you out, that little butterfly effect trick. I know it's very helpful for me. You can do that with any time you're multiplying fractions and their diagonal numbers simplify. That will always work. Question 19, dividing these decimals. I'll do a similar problem for you. I'll do negative 0 and 18 divided by, let's say, 0.09 instead of the 3. So if I were doing this, I would first I could see that my answer is going to be negative because I'm dividing a negative by a positive. And then I'm going to be putting the first number on the inside, so 0.18 on the inside, second number on the outside. And then I want to turn that outside number into a whole number, which means I'm going to need to move this over 2 places, which means I need to move the decimal on the inside over 2 places. If I move the decimal on the outside over 1 place, then I only would move it on the inside 1 place as well. So you got to make sure that you're moving it the same amount every time. And then that's going to turn my problem into 9 divided into 18, which is 2. And so my answer in this example would equal negative 2. So I actually got a whole number out of that. So use that same technique. Make sure you're just moving your decimals properly. Use that same technique to do exercise 19. Exercise 22, I'm going to go ahead and let you simplify this down, but I just want to give you the hint of using that butterfly trick. using that butterfly trick right there on those 4s. 4s will both simplify by 4 into 1s, so I'm going to leave you with that. Same thing here, we're doing some multiplication. Again, I want you to practice that butterfly effect right here on the 6 and the 8 and the 5 and the 15. So make sure you practice that. I'll go ahead and do an example for us as well. I'll do 3 6 times 2 18ths, which if I were to just multiply straight across is going to give me 6 and 108, which if I divide both of those by 2 is going to give me 3 over 54, and so that simplifies it. Both of those can be simplified by 3. I'm going to divide by 3, and then 3 divided by 3 is 1. 54 divided by 3 is going to be 18, and so I get 118 as my answer. But if I had done the butterfly effect, if I had decided to grab this guy and check for the butterfly effect, check to see if the diagonals can simplify, then this would go a lot faster, because 6 and 2, both of those can be divided by 2, and so my 2 would turn into a 1 and my 6 would turn into a 3. And then the 3 and the 18, both of those have a factor of 3, so 3 divided by 3 is 1, and then 18 divided by 3 is 6, and then 1 times 1 is 1, and 6 times 3 is 18, and so I get the same fraction as I did when I actually multiplied it all the way out, but I made this process way shorter, way smoother, didn't have to work with 108 and 54, which are some big numbers, and so it just makes it a lot simpler. So hopefully that helps you out a little bit. 36 is just kind of a sum of everything. I just want to remind you to do PEMDAS in the proper order. So you're going to do the exponent first, then you're going to take care of the division, and then after that you'll do your subtraction. So step 1, step 2, step 3. Make sure you do it in the proper order. If not, you're going to get the wrong answer. So hopefully that helps, guys. Thank you for watching. Make sure to like and subscribe. Shout out to my